All right, going to be working through the homework solutions here for section 10.4, which is the derivative. And we're going to be starting with problem 9a. That's all we have to do for this one. And we're asked to find f of 2 minus f of 1 over 2 minus 1. And they give us the function. It's back there at the beginning here. On the previous column, it gives you a graph of a parabola there. F of x is 5 minus x squared. All right, so what we're going to do here is use this function to evaluate this expression. So this is just plugging things in and computing. So first thing we want to do is find out what is f of 2. So let me go ahead and do that right here. F of 2, just plug 2 into this, you get 5 minus 4 is 1. We also need to know what f of 1 is. So f of 1 is 5 minus 1 squared is 1, so we get 4. So now just replacing things, f of 2 was 1, minus f of 1 was 4, over 2 minus 1, we get negative 3 on top, and on the bottom we get 1. So we get negative 3. You can leave it there, but negative 3 is the correct answer. All right, so on part, number 10, part A, we are looking at the same graph, same function, except this time we want f of negative 1 minus f of negative 2 over negative 1 minus negative 2. Let me make sure I wrote that down the way they have it. Yep. So same exact thing. We're going to come over here. We're going to figure out what f of negative 1 is first. So that's 5 minus negative 1 squared. When we square negative, we get positive. So this is positive 1, but then we're subtracting. That's 5 minus 1, that's 4. And then we do f of negative 2, that's this one. We get 5 minus negative 2 squared. And again, negative 2 squared is 4, but we're subtracting. So 5 minus 4, and that's 1. So when we rewrite this, f of negative 1 was 4, minus f of negative 2 was 1, over, now let's just look at this. This is really negative 1, minus a minus is plus, so plus 2. So we get here 3 over 1, which is just 3. So for 10 part A, we get 3. All right, now let's look at number 11. So for number 11, it says find the indicated quantities for the following function. F of x equals 3x squared. So part A, it wants us to find the slope of the secant line. So slope of secant line through the point 1f of 1 and 4f of 4. So real quick, graphically what's happening here is we have a parabola that opens up like this, and we're going to the point x value of 1 and plugging in, and that gives us f of 1. That's how tall this function is there. Then we're going to 4, and we're plugging in, this is f of 4, and we're trying to find the slope of the line connecting these 2 points. So that's rise over run. The rise is the difference of these coordinates, and the run is the difference of these coordinates. So that means, let me try and blow that up. That line right there goes through 2 points. We can imagine a triangle. This is rise, this is run. The rise is the difference between the y coordinates. That's these two. And then the change next here, the run, is the 4 take away the 1. Okay, so rise divided by run is this divided by this. So we have the slope of the secant line will be f of 4 minus f of 1 over 4 minus 1. All right, that's very similar to what we did in number 10, except now we have a different function. So we're going to be using this function here, computing f of 4, which is going to be 3 times 4 squared, which is 3 times 16, which is 48. And then f of 1 is this piece here, which is 3 times 1 squared, which is just 3. So this becomes 48 minus 3 over 4 minus 1. 48 minus 3 is 45 over 3, which I believe goes in there 15 times. So we should get 15. Now we want to do the exact same problem for part B, except we're going to change one thing. Instead of going from the point 1 f of 1, which was 1 f of 1, instead of going from there to the point 4 f of 4, we're going to go to some arbitrary point 1 plus h. So it's just this 1 plus something, so moves it to the right. And then up here, the value of the function there is f of 1 plus h, whatever that is. Okay? So we will find rise over run again. So our rise will be the difference between these two, f of 1 plus h minus f of 1. And our run will be the difference of these two, which is going to be this 1 plus h minus this, which is 1. So that's what I'm going to set up over here. So let me change this. This was to 1 plus h, f of 1 plus h. And so I'm going to take my rise, which is f of 1 plus h minus f of 1 over the run, which was 1 plus h minus 1. Let me just make sure I'm doing what they wanted. Yes, okay. So now, just like we did before, we need to plug things into our function and figure out what they are. I'm first going to figure out what this top left is, which is f of 1 plus h, and then I'm going to figure out what f of 1 is. Now, f of 1 plus h, this is the first time this has happened. We actually have a variable that we're plugging in, not a number. I mean, it's a number plus a variable, so the answer should have h in it. So I'm going to replace this x with 1 plus h. So I'm going to have 3 times 1 plus h, that quantity squared. I actually have to go square this now. So I have to do 1 plus h times 1 plus h, and I have to FOIL. When I do that, I get 1 plus h plus h squared. And then I can combine my like terms, and I get this. So I'm trusting that you can multiply that out and get to this. That's just this part. I still have a 3 in front. So 3 gets distributed to all three of these things. 1 plus 2h plus h squared. I'm going to go ahead and move this down. And then that's going to be 3 plus 6h plus 3h squared. So that's what this is. Now we need f of 1 also. Okay, we need f of 1, which we did earlier. It's just going to give us 3. All right, so now let's come back here and let's figure out what this is. This should be equal to, and I'll move this over, f of 1 was 3. Okay, it should be equal to f of 1 plus h, which is this, 3 plus 6h plus 3h squared, minus f of 1, which was 3, all over. Now on the bottom, notice that these 1's cancel, and all you're left with is h. And then at this point, the 3's cancel out, and you get 6h plus 3h squared over h. Noticing that the top has an h, a factor of h in both of those, so I can factor an h out. This should look very familiar. Difference quotient, we had things like this happen. And then cancel the h's, and all we're left with is 6 plus 3h. And we are done. Let's make sure I'm on camera here. Yes. Okay, so the answer to this, part B, is 6 plus 3h. Okay, moving along. Use the four-step process. Use the four-step process, I'm doing number 23, to find f prime of x, f prime of 1, f prime of 2, f prime of 3. Okay, so number 23, they give you a function. The function is 2 minus 3x squared. So there's the four-step process, right? But ultimately, here's what we want. Okay, at the end of the day, the 4 steps just get us to a final answer. This is what we want to do at the very end. We want to take the limit as h goes to 0 of the difference quotient of this function. Right here. This is known as the derivative of the function, which I'm sure I discussed in class. And we notate that f prime of x. So this is our main goal, all right? So they have a 4-step process. I kind of have a different process. I always start off by just figuring out what the top left corner of this difference quotient is. The top left corner is what you get when you plug x plus h into that function. So we get 2 minus 3 times x plus h, that quantity squared. So notice I'm squaring the whole x plus h, and that means I have to FOIL it. So I go and I do x plus h squared, and I do x times x, I get x squared, x times h, I get xh. I do x times h again, I get another xh, then h times h, I get h squared. These two can combine together, x squared plus 2xh plus h squared. So that's what happens when you square this, but we still have a 3 in front of it. So 3x squared plus 2xh plus h squared, and then distribute. So 2 minus, distribute your 3 through here, 3x squared minus 6xh minus 3h squared. Okay, anything clean up there? No, that's it. That's ugly, but that is the top left corner. That is this piece right here. That is all of this junk right here. Now, we need to know what f of x is. Well, f of x is just that, right? I mean, there's nothing to do here. F of x is just 2 minus 3x squared, okay? So let's go ahead and rewrite this. This is going to be equal to the limit as h goes to 0, and then f of x plus h, which is this, 2 minus 3x squared minus 6xh minus 3h squared minus, now very important here, this has 2 terms, so I must use parentheses here. We've seen this several times. And all of this over h. We've seen the difference quotient before. Okay, this is the difference quotient right there. Now, the only thing we're adding to the difference quotient is we're taking a limit, and we're going to take the limit at the very end. So let's try and simplify this first. If I distribute this through, this negative, I get a negative here and a plus here. So I'm just going to erase this, make that a plus. That's what would happen if I distribute that negative through. And when I do that, good things happen. Negative 2 and positive 2 go away. Negative 3x squared, positive 3x squared go away. And notice that everything I have left has an h in it on top. So I'm going to rewrite this. Notice I'm also keeping the limit here because I have not let h go to 0 yet. And I will also point out that if right now I let h go to 0, we get 0 over 0, which is an indeterminate form. That's a bad situation. And whenever we have 0 over 0, we want to do some algebra. And the algebra we're going to do here is just factoring the h out. So we've kind of been building up to this whole idea, and now we're utilizing it. Okay, so I pull out an h from here and one h from here, and this is what I'm left with. All of this divided by h. h's cancel. And so now here's where I am. Equals limit. H goes to 0. And all I'm left with was what was there in parentheses. Negative 6x minus 3h. And now I'm going to let h go to 0. Not x to 0, h to 0. So if h gets directly substituted in here with a 0, this thing goes away, and all I'm left with is negative 6x. And that is the answer. That is f prime of x, which represents the slope of the tangent line to this function at x. So that answers the first part of the problem. I wanted f prime of x. Now I need f prime of 1, 2, and 3. So f prime of 1, f prime of 2, and f prime of 3. So now all I'm going to do is plug 1, 2, and 3 into f prime of x, which is this. So if I plug 1 in here, negative 6 times 1, I get negative 6. If I plug 2 in there, I get negative 6 times 2, which is negative 12. And if I plug 3 in there, I get, wow, what am I doing? Negative 18. Those are our three derivatives. Now, big picture, what's happening here? We have a function. We have a parabola that opens down because there's a negative 3 in front. It's actually, if you graph it, here's 2. It goes like this. Like that. And what we've discovered is that if you go to 1, out here, 1, and you go up to the function, you have a tangent line. And the slope of that tangent line is actually negative 6. So we know it's pitched down. Now my drawing's not very good, okay, but it's pitched down. It has a slope of negative 6, which means that line you go down 6 over 1, down 6 over 1. But if you move to 2, which is a little further out, and go here, our tangent line's like that. So look, it's steeper. It's negative, but it's steeper, which is why you get negative 12. And if you go out to 3, let's say 3 is here, to the graph, and look at that tangent line, it's even steeper, which is why it's negative 18. So the derivative allows us to find the slopes of these tangent lines at any given value of x. And I'll just point out right now, even though it's not asked, that if I take the derivative at 0, it's negative 6 times 0, which is just 0. So if you go here to 0 and go up on the function, the slope of the line should be 0, and that means it would be flat. That matches up with the slope of 0. So this is going to be what we're, the whole idea here is for us to be able to maybe figure out where the tops of functions are. I actually know right now that the top of this function, the highest point, happens when I plug in 0 to the function. When I plug in 0 to the function, it spits out 2. So this point lives on my graph, right there. That point's the highest point on the graph, which actually, because this is a parabola, means that that's the vertex. And so if we use the vertex formula on this, we would have gotten this. But let's not worry about it right now, okay? All right, let's look at number 25. 25 has the same set of instructions, but they give you a different function. So the function here is x squared plus 6x minus 10. We need to find f prime of x, which we know is the limit as h approaches 0 of f of x plus h minus f of x, all of that divided by h. So let me do some work over here. Let's figure out what f of x plus h is. Well, that means I'm going to plug x plus h into this right here and here. So I'm going to have to take x plus h and square it, plus 6 times x plus h again, and then minus 10. So I've got some work ahead of me here. I need to square this, which means I need to FOIL it. Now I'm not going to FOIL it on camera. I'm just going to trust that you could multiply this times itself and collect like terms and get this. And then I'll distribute a 6 through. and then I have minus 10. Nothing here collects. We have no like terms, so that, unfortunately, is the top left part of this fraction. Okay? Now, the top right part of this fraction is just this function itself. So I think I'm ready. I'm just going to write it all down. Limit h goes to 0. Here we go. This part, big ugly thing, x squared plus 2xh plus h squared minus 6x minus 6h minus 10. Okay, that's this part. Why did I put minus? I don't know why I put minus. Plus, plus, that's minus. Okay, all of that. Then we have minus, that's this, and I'm subtracting this right here. So in parentheses, x squared plus 6x minus 10, then this entire ugly, nasty thing divided by h. Yes, that looks ugly, but good things are about to happen. So the minus needs to pass through. Minus this, then this will be minus the 6x, and then minus minus is plus. So that changes to a plus, that changes to a minus, this is a minus. So I've dropped my parentheses by distributing. And now I get my real nice cancellation. I should get everything to go away that doesn't have an h in it. Right there. So everything that's left has an h. 2xh plus h squared plus 6h. That's all I have on top. It's this, this, and that. And then all of this over h. Now right now, if you were to take that answer and let h go to 0, you would get 0 over 0, because it would zero everything out here and 0 here. That's bad, so we do some algebra. The common theme here, we're going to factor out the h on the top, cancel the h, and then one more line. I'm going to just rewrite what I have here. Okay, after the h's cancel, I just have this. And now I let h, not x, I let h go to 0. That kills this guy off, and all I'm left with is the 2x plus 6. Okay, so here's what I know. This is the original function, but its derivative is 2x plus 6. Now I can use that now to answer the other questions in the problem. The other questions were f prime of 1, f prime of 2, f prime of 3. So these things will give us the actual slope of the tangent line of this function at those specific points. And so I'm just going to plug 1 into the derivative. 2 times 1 plus 6, that's 8. 2 times 2 plus 6, that's 10. Then 2 times 3 plus 6, that's 12. There we go. So our answers for the problem are this, 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 and this. All right, number 27 is exactly the same. We want to do the exact same thing, but again, a different function. This function is a little more complicated. It's still a quadratic, but it's got a 2 here in front of the x squared, which makes things a little bit messy. Minus 7x plus 3. Makes it a little bit messy, but I think we're going to make it. All right, let's do it. Let's do it. We're trying to find the derivative first. So the derivative of this function will be limit. Don't forget the limit. H goes to 0. F of x plus h minus f of x all over h. All right, let's figure out some things here. I need to know what f of x plus h is. So I'm going to plug x plus h in here. So I have 2 in front, then x plus h, that in parentheses squared, minus 7, then in parentheses x plus h, and then plus 3. Now, I need to expand this part. This squared, we've done that several times, but remember there's a 2 in front of it now. Okay, so in parentheses, that's just that expanded. I've got the 2 ready to go. I've got negative, let me go ahead and distribute that negative 7 through. Negative 7x minus 7h, then plus 3. Let's go ahead and pass that 2 through. 2x squared plus 4xh plus 2h squared. Then continue, minus 7x minus 7h plus 3. Nothing here combines together, so that unfortunately is the top left part of this. And then I'm going to subtract f of x, which is this, and then divide the whole thing by h. I hope you're catching on to the kind of repetition that we have here. It's the same kind of format on all these problems. We just have to be careful with all this algebra. If you mess up like one sign on this, it's pretty much over. Okay, that's this part. Then minus f of x. So I'm going to subtract this. Let's see if you can do this time. Change the signs while you do this. Since I'm subtracting all of this, it's going to make this negative, positive, and negative. So it'll be minus 2x squared plus 7x minus 3. Then all of this divided by h. Notice how I'm just very clean. I write down the formula, equals, limit, then I rewrite everything. I'm not just like doing like crazy jumbled stuff. I'm keeping everything organized. That's what I'm looking for here. Cancel, cancel, cancel. And the only things left should have h's. So this, those two are there, and that little piece in there is still there. So we have limit as h goes to 0. We have 4xh minus 2h squared minus 7h all over h. If we take that limit, we get 0 over 0. So we're going to do some algebra. We pull the h out on top, factor that h out, and then cancel the h's. And now all you're left with is this. So again, I write the limit one more time. H goes to 0. And I have in here 4x minus 2h minus 7. Now if I let h go to 0, it's going to kill that entire term off. And all I'm left with is 4x minus 7. That's my derivative. There we go. Very nice. Now I can answer the other questions. What's f prime of 1, f prime of 2, f prime of 3? So if I plug 1 in here, 4 times 1 minus 7, that's negative 3. 4 times 2 minus 7, that's going to be 8 minus 7 is 1. 4 times 3 minus 7, that's going to be 12. Take away 7, that's 5. There you go. All righty. Moving along. Number 43. Number 43, you're only supposed to find in 43, it actually has a picture up here, and it gives you a function f of x equals x squared plus x. And for part C, it says find slope of tangent line at 1f of 1. So we have two options here. We can actually go and use the formula but replace our x's with 1s, or just do what we did before, figure out what f prime of x is, and then this is saying, right here, find the slope of the tangent line at this point means that we want x to be 1. All right? So this whole thing is really asking us to find f prime of 1. That's what it wants. The slope of the tangent line at 1 is this. So if I find f of x first, or f prime of x first, then I can plug 1 in after I'm done. So let me do that. It's kind of what we've been doing this whole time. Limit h goes to 0, f of x plus h minus f of x all over h. So realize that I can do it this way, or if I wanted to, because they only want the slope of the tangent line at one point, I could just replace that with 1, that with 1, that with 1. But I'm going to go and do it in the more general sense. I'm just going to get the derivative. So now this is equal to limit h goes to 0. I need to know what f of x plus h is. So I'm not going to do this on the side anymore. I'm just going to do it right here. I need to replace that with x plus h and that with x plus h. So I have x plus h squared plus x plus h. That is what I get when I plug x plus h into this right here. Then I will subtract from that f of x. So I'm going to subtract this thing, which makes this minus and minus. So minus x squared minus x. Then all of this over h. Now, I have to clean this up. I have to square that. I can drop the parentheses here because there's like a 1 out here, but I do need to square that first. So this is limit h goes to 0. When I square that, we've done it several times, I get this. Then I still have plus x plus h. Then I have minus x squared minus x, then all of this over h. Good things should happen here. X squared's gone. This x is gone. Everything else is okay, but they all have h's in them. So watch this. I'm going to skip another step. Since they all have h's in them, I'm going to go ahead and factor that h out now. So I pull an h out of this, I'm left with 2x. Pull an h out of this, I'm left with h. Pull an h out of this, I'm left with 1. So there's the h that came out. All over h. Cancel. And then at this point, I'm going to skip another step. I'm not going to rewrite it. I'm just going to take the limit as h goes to 0. So if this goes to 0, it's gone. And all you're left with is 2x plus 1. Bam. That's our derivative. Now, this wanted to know what was the slope of the tangent line at 1, at x is 1, which means I want to plug 1 into that. So f prime of 1 is 2 times 1, because I'm plugging 1 in for x, plus 1, and this is 3. So that is the answer to part C. Sorry, that's all they wanted, part C. Now part D. Part D is a little bit different. Part C wanted the slope of the tangent line. Part D wants the equation of the tangent line. Okay. Well, what's the difference? Well, look, this is the standard form of a line, mx plus b. The slope of this line is m. But the equation of the line is the whole thing. So what we did in part C is we found just the slope of that tangent line. We never found the equation of the tangent line. So to find the equation of the tangent line, I need to get it to look like this instead of just this, which is just a number. But realize that that 3 is the slope of this line. Now, the only way to come up with this equation is if I have the slope in the y-intercept, or if I use this equation of a line, which we used earlier this semester, if I have a point and a slope, I can find the equation. I know I have the slope. The slope is 3. But do I have a point on this line? Well, yes, I do. Here's the point. This is the point. X is 1, right? So imagine in this function, if I were to graph it, whatever it looks like, it's a parabola, but if I were to graph it, if I go to 1 and plug in, I should get some value. It's actually over here. If I plug in 1, I get some value. So what happens if we plug 1 into this? So in other words, what is f of 1? Well, that's 1 squared plus 1, that's 2. So this point right here is actually the point 1, 2. And that's our x1, y1. And so we just come back over here. Y minus y1 is 2 equals m. M was this slope, 3, and then x minus x1, which was 1. And now we have a nice equation. Let's make it look like this. So let's solve for y. Distribute the 3 through over here, and then add 2 to both sides. Adding 2, so add 2 to -3, and I get just -1. All right, there it is. So this says that if we were to graph this parabola, okay, and then go to x equals 1 and go to the graph, there is a tangent line through here. And that is the tangent line. If we were to graph that line, it would come through and hit that graph right at that point, and it would run tangent to our curve. Okay. Last problem, number 79. All right, they give you a revenue function. R of x, so that's just like f of x, but we're calling it R of x, is 60x minus 0.025 x squared. And they're telling you that this exists on the interval 0 less than or equal to x less than or equal to 2400. So this is our revenue function. It says for part A, it says find the average change in revenue if production is changed from 1,000 car seats to 1,050 car seats. So in other words, they want to know the change in revenue from x equals 1,000 to x equals 1,050. All right. So what this means is we need to find the slope of a secant line because this is the average change. And it's between 2 points, not at a single point. If we want to know the change at a single point, that's the tangent line and that's the derivative. But this part A is just asking for an average rate of change, which means we're talking about a secant line. So we want to imagine the x being here at 1,000 and then let's say 1,050. Our function, give me just a second. Okay, so sorry about that. So what we're saying is that this revenue function, whatever it does, okay, whatever this revenue function does, we want to know at 1,000 it has some value, right, some y coordinate, and then at 1,050 it has some other y coordinate, and we're trying to find the slope of this secant line. So we're going to do a little rise over run again, and it's going to be the difference in the y coordinates over the difference in the x coordinates, which will be again r of 1050 minus r of 1,000 over 1050 minus 1,000. Make sure you understand there what I'm doing. I'm taking the rise over run, the difference in the y coordinates, which is the function's value at these two points, and then dividing it by the difference of the x values, which is the difference of these. Now, I probably need my calculator for this. I need to actually plug in 10,050 into here. So I'm going to go 60 times 10,050 minus 0.025 times 10,050 squared. Come on. Make sure I type that in all right. Okay, looks good. So plugging this number into that function, trusting you can do that on your calculator, 35,437.50 minus, now we plug 1,000 into that. So 60 times 1,000 minus 0.025 times 1,000 squared, and you should get 35,000. All over 1050 minus 1,000, that's just 50. So now I'm going to do that top. So we should get 437.5 over 50. 8.75. So what does this mean? Our revenue is changing by $8.75 per car seat. So if you're going to go from 1,000 selling 1,000 car seats to 1,050 car seats, our revenue is changing on average of $8.75 per car seat. So if I increase the number of car seats by 1, on average, not following the graph, but on average, it's going to change by $8.75 per car seat. So you can see here that if I zoom in on that, we have the curve, we have the 2 points, and we've approximated that curve change, we've approximated it with a line, and that approximate change, or that approximation to the change is about $8.75 per car seat. Now, what we're going to do next, part B, is find R prime of X. Because what's interesting to us in this class is not the average rate of change, but we are more interested in exactly at that point, what's the instantaneous rate of change, and that will require the derivative, which requires calculus, which requires algebra, and that's why we're taking this class. So I need now R prime of X for part B. This is going to be a mess. Okay, by definition, R prime of X is the limit as h goes to 0. Now, instead of f of x plus h minus f of x, I'm going to put r of x plus h minus r of x because I'm using the revenue function, not the generic f function. All of that divided by h. Now, let's write limit h goes to 0. And now I'm going to do this piece right here first. I'm going to plug x plus h into this. So 60 times x plus h minus 0.025 times this squared, but that's x plus h. So x plus h squared. Okay, so we've got this top left piece taken care of. That's it right there. Then we have to do minus this, which changes this positive to a negative and the negative to a positive. So minus 60x and then plus 0.025x squared. This entire thing divided by h. Still have some algebra to do here. I must expand this, then distribute this decimal through, which is going to be a mess, and then I have to distribute a 60 through here. So let me go ahead and do this. Limit h goes to 0. I have 60x plus 60h, that's here and here, minus 0.025. Then I'm going to expand that, which we just have done so many times now. I know what it is. That's what this is. And then just rewrite these minus 60x plus 0.025x squared. All of this over h. Okay, nothing cancels yet. We still have to take this negative 0.025 through the parentheses. That's going to suck. Let's do it. Keep going. Keep going. Don't give up. All right, this equals, still writing the limit. All right, 60x plus 60h, okay? Now, when I distribute this to here, I'm going to get a negative times a positive, so it's going to be negative 0.025x squared. And then we do this times this. Now, just to make sure you're not making any mistakes, we're going to get on our calculator, we're going to take negative 0.025, and we're going to multiply that times the 2 here so that we can get the constant in front. That's 0.05, but it's negative. So negative 0.05 x because xh because it was xh, and then finally this times this, and again there's a 1 here. There was a 1 in front of x squared, which is why we got that. So it'll be minus again, minus 0.025 h squared. So we're done with the distribution. Then we still have this, minus 60x plus 0.025 x squared. All of this, all of that over h. Goodness gracious. All right, cancel stuff. Let's go. Cancel, cancel. Please. All right, 60x gone. Hey, 0.025x squared gone. Everything else has an h in it. H squared, h. All right, we're pretty much there. So I'm going to try and kill a couple of birds with one stone here. I realize that in the numerator, I'm going to have the ability to factor an h out. So let me go ahead and take an h out of all of these. H. Now I'm left with a 60 here. Here I'm left with a minus 0.05x. And then here I'm left with a minus 0.025h. And that's all over an h. And these h's cancel. And now I can finally take the limit. And when I take the limit, hold on just a second, let me take this call. Okay, when I take the limit, h goes to 0, it's going to kill this entire piece off. And all I will be left with is 60 minus 0.05x. This is my derivative. All right, so r prime of x, the derivative, which represents the slope of the tangent line to the function at any provided value of x. You give me a value of x now, I'm going to be able to tell you the slope of the tangent line there. So I'm guessing that part C, yes, part C says find the revenue and the instantaneous rate of change of revenue of production level 1,000 car seats. Okay. So what happens if we produce 1,000 car seats? Produce and sell 1,000 car seats. 1,000 car seats. So what if x is 1,000? Well, we know that the revenue at 1,000, that's the money we'll bring in, can be determined by plugging that into here. So what happens when we plug 1,000 into this? I think I did that earlier. It came out to be 35,000. So we'll make $35,000 in revenue if we manufacture, produce, and sell 1,000 car seats. The second question is the calculus question. It's saying, if you do this, how fast is the revenue changing at that instant? So when you produce this many, is your revenue going up or is your revenue going down? Well, to do that, we need to find r prime of 1,000. And to do that, we plug into this one. So it's 60 minus 0.05 times 1,000. And You could probably do that arithmetic in your head maybe, but this is 10. And it's $10. All right. So I'm going to go back to part A. Part A said, hey, look. Part A said, look between 1,000 and 1,050. And we had this curve like that. And we approximated that the average rate of change was about 8.75. So it was $8.75 was the average rate of change from here to here. This part of the problem is saying, using calculus, tell me the rate of change, the instant rate of change at exactly 1,000. So you no longer have 2 points. This point moved over and got right on top of that one. And we figured that at here, the rate of change is 10. And see, knowing the rate of change at a specific production value is better than knowing it on some interval, because this is only an average. This is exactly what's happening. Exactly what's happening. So we've got a pretty significant rate of change in revenue at that production level. That's pretty good. I think we're done.